So in a way, a dot product is pretty simple. It's just multiplying two vectors. So let's do that. That's the first one of the things that we're going to do, is to find a dot, let's change that to the right word, product. So that's mathese for multiply two vectors. So let's take one vector, which is equal to negative 8i minus 3j. And then this one, w, is equal to negative 10i minus 5j. Lots of negatives in there to have fun with. So here, the method for this one is relatively simple. You just have to remember it. If we're going to multiply v times w, that's going to be equal to a1 times a2 plus b1 times b2. So let's identify the a's and the b's. These are a and these are b. So a1 and b1 from the first one, and a2 and b2 from the second. So we're simply just using the coefficients, and we just multiply it out. So that means v times w will be equal to negative 8 times the negative 10. Got the negative 8 as the coefficient for I for this one, and negative 10 for the coefficient for I for the second one. And then we'll do it with the j's. So the b's will be the coefficient for the j's, plus negative 3 and negative 5. So v times w equals positive 80 plus 15. And so v times w equals 95. So remembering this little formula is key, and then remembering that the a's and the b's are the coefficients, and that this one's not really a hard problem. Okay. So if you have room, just keep going on the same paper. I write big on these, so I will be using another piece of paper for this one. This one will take a little bit more space too. So this is still 6.7. And actually, I'll number the pages here. This is page 2 of 3. We're going to have 3 pages for this. And this is part 2. Find the angle between two, that's supposed to be 2, vectors. Okay, let's go over what I mean by that. I'm going to take these two vectors, I plus 2j, and w is 4i minus 3j. So we're going to graph those. I'm going to make a little basic hand graph here. Now I'll go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I don't need to go this way, but I will anyway. 5. So negative 5, positive 5, negative 5, positive 5. Basic hand graph. So we have to remember that the coefficients of the i's, we called them a and a before and then b, but they're also x's and y's. So for this one, that vector is going to be the x coefficient here is 1, and the coefficient here is 2. So let's graph 1 and 2. And that's a vector that's going up to here, and if we continue it, it goes way out this way. So we have a vector that's going out to here. And then we have a vector, it actually stops, it goes up to here, but we're going to keep it going because it's easier to see the angle. This one has an x of 4 and a y of negative 3. So let's go 1, 2, 3, 4, and 1, 2, 3. So we have one of them going out this way and one of them going out this way. The angle between the two vectors is this angle here. the acute angle between them. So we need to find that, and here's the formula for it. So the formula to find the angle between two vectors is this, that the cosine of theta is equal to v times w. Remember, we just did that kind of thing. That's a dot product. And underneath it, we do the magnitude of the first one times the magnitude of the second one. In a way, it's a relatively simple type of rule formula because it's the dot product and then the two magnitudes, which aren't that hard to find out, but we need to find them out. We're going to have to calculate the dot product, then we're going to have to calculate this magnitude and calculate this magnitude, and then do some multiplying and dividing. So I consider step one to be doing v times w, which we just did before. Remember now, a and b. So by saying x and y and x and y, I'm also saying a1, a and b1, a2 and b2. So that means I'm going to do 1 times 4, a1 times a2, plus b1 times b2. So I'll write them up here so as a reminder. a1 times a2, b1 times b2. And that equals, this is 4, and that's minus 6, so plus a negative 6 is minus 6. So we get a negative 2. So in a moment, we'll put a negative 2 on top. So the next thing we need is the magnitude of v. And you get that by essentially finding that distance. We use essentially that distance formula here. So, but what we do is we square these. So it's 1 squared plus 2 squared. Well, that equals the square root. Well, that's 1 and 4. 4 plus 1 is 5, so that's square root of 5. Third, we need the magnitude for w. And we're going to do the same thing. We're going to do the a squared plus the b squared. Equals here. So this one's going to be 4 squared plus negative 3 squared. Well, that equals 16 plus 9. So square root of 25, which is just 5. So we've just identified v times w, the magnitude. I guess I'll do longer dashes for them here. Because I'll just go ahead and do boxes. Identify it. So that's the result up here, and then these two on the bottom. So now let's do that. Cosine of theta is equal to negative 2 over square root of 5 times 5. So we want to know what theta is. So first, let's make sure it makes sense what we did here. The cosine of theta is going to be this, and this, and this. And we just found this, and this, and this. Put them together. Now, I could multiply them and all that, but really, let's let the calculator do the work. Because if we want to find out what theta is, that means we need to say cosine minus 1 of whatever of the cosine of finding angle. And let's see what that comes up to. By the way, don't forget, when you do your calculator, some people have a little difficulty with this on the test, that when you graft trigonometric stuff, your mode you had in radians. Take it out of radians when you're doing other calculations. You only want it in radians for the graphing. You get a different answer and don't even realize it sometimes. And some of you should have, because you get a negative answer for some things when it shouldn't be negative, so it should tell you, go look at the radians. So I make sure it's in degree, and now I'm going to do cosine minus 1 of the, now here I have to be careful, I'm going to put parentheses, negative 2, and divide that. I may not need it with the other parentheses, so I'm being real careful here. I mean, a whole thing there on that. And I'm going to do parentheses, square root of 5 times 5. So I'm telling it negative 2 on top of, and in parentheses is at the bottom, square root of 5 times 5. So I get 100.304 100.3048 or 305 degrees. Usually we either round to the tenths place or to the single place. In this one, I didn't say which way. I think it makes most sense just to say 100 degrees. So theta equals, that's the angle. So that's the angle between these two. It almost looks like a right angle. When we graphed this up here before, it almost looked like it was a right angle, but it's not. It's a little bit more than a right angle. And that's why you can't trust your eyes. Yeah, you want to calculate it out. So let's review here that you're using this formula to find the angle, or to find the cosine of the angle. Once you find the cosine of the angle, you use cosine minus 1, and that will tell you that angle. So the answer to this one, the angle between the two vectors, we now know is 100 degrees between those two. Okay? And that's how you figure it out. Two parts. You figure out all that, and then you do the minus 1 to get the angle. So that's the second of three things here from section 6-7. Let's look at the third one now. The third one is orthogonal angles. 3, 6.7, and this is page 3 of 3. So, orthogonal. I'm not even sure if I'm pronouncing it exactly right, but that's good enough. It looks like that, so that counts. Orthogonal simply means a 90-degree angle. It means 90 degrees. Now, you have orthogonal angles only if it equals 90 degrees. So, and that's the meaning of it, but here's what you do, is if the dot product is 0, then the vectors make a 90-degree angle. Oops, let's make it there. So that's what you need to know, which means if you want to find out if two angles or two vectors make an orthogonal angle, you need to multiply them and see if you get 0. So let's do that with these two. V equals 8i minus 4j. W equals 6i minus 12j. Okay? So using those two, if we're going to multiply them, remember that we need the two a's and we need the two b's, which are both negative. Interesting. Okay. So we're going to do v times w equals 1a times the other a plus 1b times the other b. So we're going to multiply these two and multiply these two and add them. So v times w equals 8 times 6, negative 4, and negative 12. V times w equals 48 plus 48. It equals 96. No. Not orthogonal, something like that. This is a really good problem because if somebody made a mistake with a negative and got this as negative 48, they'd get a 0 and they'd think it is orthogonal. So it would be sort of a testing, can you do your negatives right? If you do, you realize the correct answer is no, and if you do your negatives wrong, you end up thinking it is orthogonal and you're wrong. So be careful with your negatives. So yes, I purposely set that up so that to emphasize about the negatives again. But that's all you have to do is you do the dot product and see if it comes to 0. And if it does, great. If it doesn't, it's not orthogonal. So notice in all three of these, they have the common thing of doing the dot product, of multiplying it, multiplying the a's and the b's and adding them together. That was the first part. Then the second one, we used it for finding the angle. And the third one, that is how we use it to see if it's 0 or not. So those are the three things in section 6-7 to know.